Hey, all you math fans out there. I'm gonna guess when I start editing this video that I am going to be looking like a headless horseman. In reality, I'm gonna have to go and coach after this quick math lesson, so don't worry, we're gonna get into the math in a second. Today, we're gonna look at scientific notation, specifically multiplying and dividing. All right, let's get to it. Go east.
Think of a giant number right now. Do you have it in your mind? Is it a big number? Is this your number? And if this is your number, this is going to be awesome. Is this the number? Is this the number that you were just thinking of? 5 billion. Okay, so if it's not your number, I mean, the chances of it being your number is pretty small. But if it was your number, that was really cool. So 5 billion. So scientific notation is where we take giant numbers like 5 billion and we make it more manageable. And we can also take those really tiny numbers. So these really super duper small numbers. Like we're talking super small numbers like that. I'm not even gonna try and say whatever that is. And we make them manageable again. So it's pretty cool. It's really useful. It's used for, again, probably with, we're dealing with large and small numbers, but we're talking about space, like how far is it from here to the sun? And, things like, how small is that little tiny atom that you might be studying in science? So here we go. So what is it all about? So basically, scientific notation says everything has to be times 10 to the something, okay, always. And what the other part of scientific notation is, it's always one digit and then a decimal. So stuff like 6.8, okay, times 10 to the whatever. So you can never have this digit be bigger than 9. So you can't have like 10. Okay, so the big thing that I always say to kids is when you're doing scientific notation, there are two things. Number one, it always has to be times 10 to the something. The second thing I tell them is that you can only have one digit, and then the decimal. Okay, you can't have two digits. So you couldn't have things like 14 times 10 to the 7th because it's two digits here. You couldn't have 18.2 times 10 to the 6th. Okay, you can't have that because there's two digits here. You have to have things like 7.1 times 10 to the negative 4. And what? Is there a negative exponent? Didn't you just say we shouldn't be always using negative exponents in the previous lessons? Why, yes, but for scientific notation, you can have negative exponents. That's allowed. So that's okay. So do realize that. So those two things. Got it? Good. Let's go and figure out how to go and work with this, shall we? And there's some complicated rules, et cetera. But let's just take, let's go back to our 5 billion. And just to make a very point that my decimal point is there. Okay. So I want to go and move the decimal point to a point where I have, to a point where I have only one digit and then the decimal. So I got to move it. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get the number of 5. Okay, you can say 5.0. What is this 5? And it's going to be times 10 to something because it's always going to be times 10. And then the other part is going to be like, so how many times did you move the decimal? So I moved it like 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's times 10 to the 9th power. And that's it. That's now in what we call scientific notation. So there's a couple things. There's scientific notation, and there's everything else, which the opposite, so the opposite would be standard. So we got standard notation. So standard notation is like this one, and scientific notation is like this one. Okay. So that's times 10 to the 9th. Now, let's say you had to change a really tiny number. So 0.00000 0, 0, 1, 2. Okay, same sort of thing. I gotta move this decimal all the way until I get one digit and then the decimal. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So I'm gonna have 1.2 times 10. Now if I said to the 8th, I can understand that. But ask yourself, is this a big number or a small number? It's a small number. So it's times 10 to the negative 8. So that's what, there's some rules I could teach you, but let's just put it into kids' perspectives. If it's a small number, and I think we can all agree that 0.0000000012 is small. If it's a small number, you get negative exponent on that 10. And if it's a big number, okay, like that 5 billion that you just had, you're going to have a positive exponent on the 10. Does that make sense? I hope so. All right, leave that there. That looks nicer. So got to keep that in mind. That's an easy way to kind of think about it. Okay. So you've gone one way. You've changed standard notation to scientific notation. And you're going to be asked to do the opposites as well. So you have to be able to go and do the opposites. And what would that look like? Well, it's like if you have stuff like this. Say I had 7.2 times 10 to the 4th. And I said, put that in standard notation. Okay, so I need to take that 7.2. And I'm going to first ask myself, is this going to be a big number or a small number? Well, it's a positive number here. It's a positive exponent, right? So I'm thinking it's going to be a big number. Because this really means 7.2 times 10 times 10 times 10 times 10. So I'm going to move my decimal 4 places to the right. 1, 2, 3, 4. And I'm going to fill these in with zeros. So if I had to go and expand this, my answer would be 72,000. And the opposite is also true. Let's say I had 6.8 times 10 to the negative 5. I'd have to go and move my decimal 5 places to the left. It's going to be a small number. 1, 2, 3, 4, 5. And there's my decimal. Fill these in with zeros. And that would give me the amazing number of 0.000068. So that's transferring from scientific notation to standard. So hopefully you have some ideas of how that is working. Now we also need to go and talk about what does multiplying and dividing also be, what is that looking like? So we got to take a look at that. So when we're multiplying our scientific notation, we have to go back and just remember a couple of things. And one thing that we have to remember is when you're multiplying things that have the same base, so x to the 7th times x to the 5th, that would be x to the 7 plus 5, because we add the exponents. So that would be x to the 12th. And also, we must remember, if we're dividing, so you had x over 12 divided by x to the 3rd, we have to subtract our exponents. So that would be x to the 12 minus 3. So that would be x to the 9th. So that's one little thing that we must remember. Okay? Awesome. So here we go. How do we multiply our scientific notation? Well, let's start off with a fairly nice and easy example. 1.5 times 10 to the 12th, which is a really big number, times, let's just do 4 times 10 to the 7th, also a very big number. So what you have to do here is, you might be thinking a little bit of FOIL. It's not quite like FOIL. What you do is you take the numbers in the front and you multiply them. So I'm going to kind of do this a little bit slow. And I do realize that you would probably just go and do 1.5 times 4. So I just want to show you though. So that's what you're doing. So you're doing 1.5 times 4. And then you're also going and multiplying your bases like that. So it's times 10 to the 12th times 10 to the 7th. So that's what you're doing there. So, and that's really all you're going to be doing. So you're doing 1.5 times 4. So that's going to give you 6. And remember, when you're multiplying things with the same bases, you add your exponents. So this is going to be 6 times 10 to the 12 plus 7. So to the 19th. And that's your final answer. 6 times 10 to the 19th. One thing to always ask yourself, is it in scientific notation? Yes, it is. It's to a base 10 to the power, and it's 1 digit. Excellent. Let's try another example. Why, okay, Mr. Douglas. Let's try 5.1 times 10 times 10 to the 4th times 2.5 times 10 to the 3rd. Awesome. So we're going to go and again, we're going to multiply those ones together. And we're going to also multiply our base. Whoop, there we go. Base 10s together. And we're going to get 12.75 times 10 to the 7th. Awesome. All right, next question. Wait a second. Wait. Capital W. Is this in scientific notation? It is not. It is not. Because it's 2 digits. There's 2 digits here, isn't there? There's 2 digits. And we can't have 2 digits. We must only have 1 digit. So what to do? Well, we have to go and move our decimal, don't we? So I'm going to move my decimal, whoop, 1 place backwards. But if I do that, I need to go and add 1 to my exponents because I'm basically moving it by a power of 10. So my final scientific notation answer is 1.275 times 10 to the 8th. Will teachers put those kinds of questions on tests? Absolutely, just to make sure that you're paying attention. Excellent, excellent. Let's move on to some dividing. Let's get rid of that one. And let's go and think of some numbers. Maybe we should try the guessing game again. No, let's not do the guessing game. Let's do 117. You never would have guessed 117. Times 10 to the 18th divided by 6 times 10 to the 4th. Okay, so you probably going like, oh, I've got a good idea of how this is. So let's see if you can figure it out. You're going to go and you're going to divide these. So 117 divided by 6. And that is going to give you a really ugly number of 19.5. So that's going to give you 19.5. And then you're going to go 10 to the 18th divided by 10 to the 4th. So you're going to subtract those. And you're going to get times 10 to the 14th. You know that you're not done yet. You have to go and move your decimal 1 place over, which means adding 1 to our exponents there. So your final answer is 1.95 times 10 to the 15th. Now, you might also be wondering, because we've shown some different examples here and there, is like what happens if you have to move the decimal kind of the other way? So let's say you had, an answer that kind of looked like this, times 10 to the 7th, and you're like, go and change that to scientific notation. So you have to move that decimal 1, 2 over there. And what's going to happen to your current decimals here? Well, you're going to have to go and subtract 2. So when you go to the right, you have to go and subtract 2. So your final answer would be 5.6 times 10 to the 5th, like that. So do realize that you have to go and move those decimals around sometimes. So the big thing to keep in mind is have that one digit and then a decimal, and also make sure that you're always timesing it by 10 to the something. So that just about wraps up scientific notation. We got some word problem stuff popping up, but that gives you a good basis of where to start.
Okay, so for challenge, we are going to be looking at not the Headless Horseman, which is very scary, but we're going to be looking at word problems and complicated scientific notation questions. Okay, let's get at it.
Scientific notation word problems. Here we go. Let's take a look at a couple things that might pop up. Here's a question that you might be wondering. A computer can perform 4.66 times 10 to the 8th calculations per second. So we're going to change this because my font is not working very well. How many calculations can this computer perform in 1 minute? And I'm going to go and change that to seconds. So 1 minute, of course, is 60 seconds. The reason I want to do that is because we're already in seconds here. You want to keep everything nice and easy. Easy peasy. So if a computer can do all of those things in 1 second, how many can it do in 60? Well, hopefully you're saying, I got to go and multiply those. I do. So let's go 4.66 times 10 to the power of 8. So we're going to do that. Then we're going to go and multiply that by 60. Now I'm going to change 60 into 6 times 10 to the first. Hopefully that makes sense, because 6 times basically 10 is 60. So I've just quickly gone and just changed that. And now we're going to go and multiply those numbers in our base 10s also as well together. So when we are doing that, you probably need a calculator. So you're going 4.66 times 6, and that's going to be giving us 27.96. And I'm going to multiply my base 10s, which means I add those exponents. So that's going to be to the power of 9. You're being an awesome student, and you're saying, no, I must move that decimal over there to answer in scientific notation. So I will now have 2.796. And what do you do with your exponent? You have to add 1 there. So it's times 10 to the power of 10. Let's go and take a look at something else now. A different question. Get rid of that math. Get rid of that question. And if the speed of light is 3 times 10 to the... Whoa, what's that doing there? Get rid of that. There we go. It's gone. If it's 3 times 10 to the 8th, and again, I apologize for my bad font typing. If the sun is 1.5 times 10 to the 11th, so that should really read times 10 to the 11th. How many seconds does it take light to reach the Earth? Great question. This is good common knowledge. Like, how long would it actually take? Well, in order to figure that out, you need to remember, do you remember way back, in probably another previous video, how to figure out those distance, speed, and time questions? Do you remember that? Distance, speed, and time. Well, they're asking how many seconds. So we're talking about time. So to figure out time, time is distance, the distance, divided by the speed. So distance divided by speed is time. So what was our distance? How far away is the sun? Well, the sun is 1.5 times 10 to the 11th meters away. Whoa, that's far. Like, you couldn't just hop on your bicycle and go over there. And the speed of light is 3 times 10 to the 8th. Also very, very fast. So we're going to have to go and do some dividing. So when you go 1.5 and you divide it by 3, you're going to be getting 0.5 times 10 to the 11 minus 8, so to the third. Now you have to go and move that decimal 1 over there. If you move it to the right, you have to subtract. So I'm going to subtract 1 like that. So our answer is actually 5 times 10 to the second seconds. Just for fun, let's change into, like, actually how long does it take? So 5 times 10 to the second. So 10 to the second is what? 100. So 5 times 100. So it would take 500 seconds. So that's pretty neat to kind of think. From the sun to the earth, that would actually take that take that long. I find that kind of fascinating. So basically it takes about 8 minutes, just over 8 minutes or so, for something like that to happen. So that's kind of some fun knowledge to have at the dinner table conversation perhaps today. So there you have it, some word problems for scientific notation. Thanks for checking it out.
Thanks everybody for tuning into part 1 of Scientific Notation. Click a little button down there that says subscribe. That would be awesome. And maybe I'll get over 40 subscribers. There might even be a prize for number 50. So, thanks for joining in. Check out part 2 of Scientific Notation. Till next time.